Here is a simple problem to kind of use some of the things we've learned, but really this problem is going to set up, make it easier, make a proof that we're going to do in the next video easier without going through a crazy amount of steps. So here we have two isosceles triangles, one big triangle on the outside, but then we have another one here. And we're given that we have isosceles triangles ABC and ABD. ABC is the big triangle, ABD is the smaller triangle, and we're told that these are isosceles triangles, and they tell us the two sides of the triangles that are equal to each other. We have AC equaling BC, and we have AD equaling BD. So that's what we're given, and we're trying to prove that CE, this line right here, it bisects this angle, ACB, and it bisects this angle here, ADB. And so we also are trying to prove that CE is perpendicular to AB and that it bisects the base as well of both of these isosceles triangles. So here we go. Let's just get right on into it. The second step we're going to say is as our identity. We're going to say some things are equal to themselves. And so we're going to say that CD equals CD. We're going to say that CE equals CE and that DE equals DE. So here we go. All I said was CD equals itself. I said that the entire thing equals itself, and this part equals itself. And obviously that's identity. Number 3, I can now say that triangle ADC is congruent to triangle BDC. Triangle ADC is congruent to triangle BDC. All right. And we could say that because of side, side, side. We've been told already that these two sides of these two triangles are equal to each other. We were told that these two, and we just stated that that is equal to itself. So side, side, side. Those two triangles are congruent to each other by side, side, side. Number 4, we can now say that angle 1 equals angle 2. We can state that these two angles equal each other because of CPCTE. We just proved that the two triangles are congruent, and those are corresponding angles in both the triangles. So we can say they're equal to each other because corresponding parts of congruent triangles are equal. Number 5, I'm going to state that CE bisects angle ACB. Angle ACB, it bisects that angle because of the definition of angle bisectors. We have two equal angles. This angle, big angle, is cut into two equal angles. So that, by definition, is an angle bisector. So we've got number 5, definition of angle bisector. Number 6, I'm going to state now that triangle AEC is congruent to triangle BEC. So let's look at the triangles I'm trying to say. I said triangle AEC is congruent, let's get the entire triangle, is congruent to BEC. And I can now say by side, angle, side. These two are equal to each other. We just got these angles equal to each other, and we've got this line, this side, is a side in both the triangles, equal to itself. And so there it is. We can say those are equal by side, angle, side. Number 7, I can now state that angle 3 equals angle 4, and that AE equals BE. Again, let's take a look. I now state that these are equal to each other. Well, those are corresponding parts of these two congruent triangles. And so those are equal to each other. I just stated that AE is equal to BE, again, for corresponding parts of congruent triangles. So we can say that those are equal because of CPCTE. All right, number 8. I'm going to state now that CE bisects AB. We just said that it was cut into 2 equal parts, and so this line right here bisects this base here. And so we can say, because of the definition of segment bisectors. Number 9. Angle 3 and angle 4 are right angles. We really haven't said anything about them being right angles or perpendicular, but we have a definition of right angles. It states that when 2 lines meet to form equal adjacent angles, then that means these are right angles. All right, so we can state that because of the definition of perpendicular line, not perpendicular lines, the definition of right angles. Sorry, definition of right angles. We have 2 lines meeting to form equal adjacent angles. Number 10, we can now state that those 2 lines are perpendicular to each other. CE is perpendicular to AB. Number 10, we can say that because of the definition of perpendicular lines. Number 11, we can state that triangle AED is congruent to triangle BED. Let's look at these triangles here. I just stated that triangle AED is congruent to triangle BED. And we can say that for actually a couple of reasons. We've stated that, and I'll even mark these now. I've said that that's equal to that. I've said that these are 2 equal angles. We've already stated a long time ago that that's equal to itself. So we could either say side, angle, side. We could say side, side, side. And so we could say either of those. I'll put both of them down just by side, 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 or even side, angle, side. Number 12. We can now say that angle 5 equals angle 6. CPCTE. Angle 5 equals angle 6 because they're or corresponding parts of congruent triangles. And then lastly, we can state that CE bisects that vertex angle. Bisects angle ADB. Definition of angle bisector. So we pretty much now just proved everything we set out to prove. We were setting out to prove that CE bisects the vertex angles, and so we said that CE bisects angle ACB up here. Check. Lastly, we said that that bisects the other vertex angle, the other isosceles triangle. Check. We said that they're perpendicular to each other. Check. And then we also said that it needs to bisect that base. CE bisects AB, and we said that as well. We proved it all in this proof.